What's poppin', dogs? Mr. Allen here. It is a beautiful Sunday afternoon, so why not be outside doing some dope math, right? Now, really, I just want to get this review keyed, but I was like, hey, man, I'm going to do it on my Surface Pro rather than on paper. Why not record it? And hopefully you guys watch this video and find it helpful so that you can crush your last test here of the school year, man. Oh my goodness. Module 3, Topic 3, 2023 school year, right? Let's get it popping. All right, the first one here. Suppose log base A of 4 equals R, log base A of 2 equals S, and log base A of 6 equals T. Write an algebraic expression for each. My goodness, this is terrifying. But perhaps we can break this down with some log properties. Check it out. I'm going to help you guys out. I'm going to hook you up with some knowledge, all right? We got log base A of 8, okay? I could, bear with me here, log base A of, that's a terrible looking A of, how about 4 times 2? Is 4 times 2 8? Yes, it is. Now, can I break this apart with our product rule? Yes, I can. I'd have log base A of 4 plus log base A of 2. Ooh, what's log base A of 4? That's R. What's log base A of 2? That is S. So we have R plus S as our algebraic expression. See, once we break that thing down, it's not so scary, all right? Not as, well, I mean, it's still a little scary, right? But not as terrifying. Okay, next one, log base A of 2 over 3. Oh my gosh, we got fractions here, bro. We got fractions. Are you kidding me? All right, check this out. Check this out. Log base A, could I do this? Because I'm noticing some numbers like 4 and 6 right now. Is 2/3 the same as 4/6 before it's reduced? Yes, it is. So now I can break this apart into log base A of 4 minus log base A of 6, right? That's my quotient rule. It expands into subtraction. And I got log base A of 4 is R minus log base A of 6, that's T. There we go. Beautiful. Man, it's getting warm out here. All right, I want to get out there, maybe go for a little boat, float after this. But the math don't stop, baby. The math don't stop. I got to hook you guys up with some knowledge so that you can crush your test. All right, 72. My goodness. Oh my goodness. Check this out. I keep saying check this out. Of course you're going to check this out. All right, I got log base A of, now 6 times 6 is 36 times 2. Ooh, I like that. I like that. Very good. We can even do 6 squared if you'd like. But this time now what I'll do is I'll do log base A of 6 plus log base A of 6 plus log base A of 2. Log base A of 6 is T, so we got T plus, and then log base A of 2 is S, so we got 2T plus S. Beautiful. You could have, if you'd like, you could have done 6 squared, move the 2 as a coefficient in front of the log, and then get the 2T that way as well. You know, either way, whatever floats your boat, you know what I'm saying? All right, there we go. Of course you know what I'm saying. Last one here. Oh man, we got fractions again. This time it's a little bit more scary, man. You know, we got 4, but I don't have a 3, so I can't break that. What? I got an idea. Check this out. All right, we got log base A of, we could do 4 times 2, which is 8 over 6, right? 8 over 6, just for a little sidesies math. That simplifies down to 4/3, right? Right. Okay, so there we go. So now I can break this apart. Log base A of 4 plus log base A of 2 minus log base A of 6. Log base A of 4 we said is R, then the 2 is S, and then we have log base A of 6, so minus T. R plus S minus T. There we go. No big deal. Maybe one of those on the test. That's about it. All right, so these next few right here, we just want to write it in logarithmic or exponential form, so a lot of loop and swoop action. Let's get it popping. Rapid fire. We got log base 6 of C. Log base 6 of C equals 4 for that one. That's all it's asking us to do. Next one here, we've got log base 32. Log base 32 of 8 equals 3/5. That's it. That's all it's asking us to do there. That is dope. All right, next one here. Log base 4 of 16 equals 2. We can do 4 raised to the second equals 16, right? We start at the 4. The base is always the base. Pass by the 2 to get the exponent there equals 16. That is exponential form. And one more. Uno mas. We got 1/2 raised to the -3rd. That whole thing needs to be raised to the -3rd, so do not forget those parentheses there. It is paramount importance. I tried to sound fancy. I don't know if that was right. There we go. Boom. 1/2. Whole 1/2 raised to the -3rd equals 8. Nice. Little tip about this one here, right? 1/2. If I have a negative exponent, it's flipped, right? So 2 to the 3rd is 8. So 1/2 to the -3rd is 8. Nice. Cool. Let's keep it going, man. We're going to evaluate now. This freaks some people out when we're like, hey, man, you got to evaluate this. Like, what? What does evaluate mean? It means I'm just going to get a number for my answer, maybe a fraction, right? It's all non-calc, so they should be relatively friendly, right? Log base 81 of 9. So if it helps you, I'll do this on maybe one or two of these. If it helps you, you can throw an x here. And I can rewrite this in exponential form. So I'd have 81 to the x equals 9. So 81 to what power would equal 9? Well, the square root of 81 is 9, so that means that x would equal 1/2. Beautiful. So really what we should say is not x equals 1/2, but I would just say 1/2 is my answer here, okay? You don't need to write that x there, but if it helps you, cool. The way I look at it is, okay, 1/5 to what power equals 125? Well, 5 to the third is 125, and since I have 1/5, it'd be to the negative third, so negative 3 is my answer for this one right here. All right, this next one's a little bit tricky, right? We got log base 32 of 2. So 32 to what power would give me 2? Well, again, this is non-calc, so it's got to be some nicer things, right? Well, if I did 2 times 2 times 2 times 2 times 2 5 times over, I'd get 32. So that means that 32 to the 1/5 equals 2. That's pretty crazy. That one might be helpful to throw a little x there and loop and swoop it around. All right, next one, we got log base 2 of 1/8. Well, 2 to what power gives me 1/8? 2 to the third gives me 8, so 2 to the negative third gives me 1/8. And then 4 to what power gives me 64? That's 4 to the third power would give me 64, so 0 is my answer for that last one there. Nice little sum of logarithms. That's exciting, right? Something special. Oh my God, that was terrible. Okay. Use the properties of logarithms to expand the expression. Evaluate if possible, meaning if I get like log base 2 of 8, it's 3. Make sure we write that down, okay? So we're going to expand. It's going to get a little cray here. It's going to get a little cray. I'm going to go with red on this one. So everything's log base 3. So I got log base 3 of 5 plus log base 3 of x to the 4th. Now for division, it's going to become subtraction. So log base 3 of y to the 9th minus log base 3 of z. Nice. Now, can we do anything else? Well, the first one, log base 3 of 5. Nope, can't do anything with that. The next one here, I got that exponent of 4, so that can go out in front and become a coefficient. So we're going to have 4 times log base 3 of x. Same goes with these next ones. I'm going to have minus 9 log base 3 of y. And then we have no exponent for the z, so it's just log base 3 of z. Boom. Done. That's dope, man. That's super dope. All right, now we got our log base 8 here. We'll do it in a different color here so things don't get mixed up. So starts the same, right? So log base 8 of 8. And then we got plus log base 8 of x to the 1/3. And then we have minus log base 8 of y squared. I should have done log base 10, so I have to write all this. And then log base 8 of z cubed. Now I can move my exponents, evaluate if possible. Log base 8 of 8, that's just 1. Okay, 8 to the first power equals 8. Plus, and then I have 1/3 log base 8 of x. Then we have minus 2 log base 8 of y. And we have minus 3 log base 8 of z. That's it. That's dope. Expanded. Beautiful. Now, you know what? We had so much fun expanding. Let's put some things back together. You know what I'm saying? All right. Write the expression as a single logarithm. So everything's going to go back into one log, one giant log. I'm going to do it on the fly, though, because I'm crazy like that. I'm pretty fly here. Okay, so we got log. I'll make a big old log. A little more in line, maybe. I just still went up. That's okay. Second time, couldn't get it. All right, so we have subtraction, so there's going to be division within this log. And 2 of them, it looks like, are going to go to the denominator. So I've got to move this 2 up here, right? So it's going to be x squared. And then for this one here, we got the 1/3 times the 12. 1/3 times 12 is going to give me 4. So I have y to the 4th power in my denominator. And then for the z, we got z to the 5th. It was negative out front, so that goes to the denominator as well. I'll throw this in parentheses here, so it's all inside that one logarithm. That is super dang dope. All right, part B here, 13B. I know I'm going kind of quick, but I mean, this video is going to be long. So pause, reverse. What have you got to do? All right, if you got to go backtrack, that's cool, man. You can do that. All right. Once again, a big old log, baby. Big old log. So we got log base 9, and then I got to have a fraction here because I do see some subtraction, right? We've got the 4 is going to get multiplied to that 3, so I'll have x to the 12th up here. Then the negative 2/3, so the 2/3 times 9. If you got to do a little bit of side math here, oops, 2/3 times 9. So that's going to give me, that's a 3. So 2 times 3 is 6. Solve y to the 6th right here. And then we just have z. There's no coefficient in front of that z. I'll throw this in parentheses here so we know it's all inside that logarithm. Boom. Wonderful and fantastic. Man, look at that. We got one more page, baby. One more page. A lot of solving on this one, it looks like. Okay, so yeah, we got 6 solving. I can count. All right, first one here. Should be able to fit all this on one. I think so. That looks pretty good. All right. So we have 2 logs here. Oh my goodness, and subtraction, bro. Oh man. All right, so we're going to condense this into one single log here, right? We're going to condense it into one log. And when we condense with subtraction, it does become division, right? So I'm going to have log base 3 of x over x plus 2. That's my argument right there. Equals 2. Now what I need to do, oops, I just stepped on one of Jenny's toys. You hear that squeak? All right. 3 to the second power. 3 to the second equals x over x plus 2. So that's going to give me 9. And perhaps to make you feel warm and fuzzy, we can do 9 over 1 equals x over x plus 2. And we're just going to cross multiply, right? So we got, we'll bring it up here. Whoop. We get 9 times x plus 2. And then that equals x. So we get 9x plus 18 equals x. So I'll subtract to get 8x equals a negative 18. Divide by 8. Whoop. And I get x equals negative, and that looks like we can divide both those by 2, and I get 9 over 4. However, can I plug that into my original equation here? No, I cannot. All right, because I would have a negative inside of this argument here. That'd be negative. No, right? Okay, so that's a no-no, right? So extraneous here, no solution. Okay, so let's go ahead and say no. Negative 9 over 4 doesn't work. Hopefully that makes sense if someone's reading this PDF, right? You know, if not, they can check the video, right? Okay, so there we go. So no solution on that one. How sad. How sad. Alrighty. Let's go with, I feel like I want some different colors here, man. What do I want? Let's see here. Let's go with this blue color here. This looks lovely. Okay, so we're going to condense the left-hand side. I get log base 5 of, and it's going to be x times x, which is x squared, and x times negative 2, which is negative 2x, equals log base 5 of x plus 10. Cool. Now, I got the same log on each side. Log base 5, log base 5. I can use one-to-one property of logarithms and get the x squared minus 2x equals x plus 10. All right, so I have a quadratic. Now, hopefully your brain didn't just explode when seeing a quadratic outside of your quadratics unit. I got to subtract and bring everything over to one side, set it equal to 0. All right, so I'm going to have x squared minus 3x minus 10 equals 0, right? I subtracted the x, I subtracted the 10 on both sides, minus 10. Whee, show all my work. Okay, what multiplies to negative 10 and adds to negative 3? That's going to be x minus 5 and x plus 3, x plus 2. Equals 0. All right. Trying to cruise a little too fast here. Sounds like Ollie's barking at something over there. And now I get to these two factors equal to 0. So I'm going to have x minus 5 equals 0. So x equals 5. And if I plug that back in, I get a positive argument here. I get a positive argument here and here as well. So 5 is going to work. That's good. How about x equals negative 2? Well, if I plug in negative 2, I'd get a negative argument on 2 of these actually. Even if it just happened to 1, that's no bueno. So there we go, x equals 5. And yes, we can always ask questions like, hey, which of the following is an extraneous solution, right? And that'd be negative 2. But the actual solution is x equals 5. Okay. Couple more and we done, baby. Couple more and we done. All right. So here for this one, oh my goodness. These are some scary looking numbers. Hopefully we can handle this thing, right? So I'm going to divide by 2 on both sides to start this thing. Divide by 2. I get 9 to the 4x minus 3 equals 27. All right, well that sucks because I don't have my calculator right now, so I can't loop and swoop and plug it in, math alpha math this thing. No, I got to think. I can use my brain a little more. I can rewrite 9 as 3 squared, and it's still to the 4x minus 3. I can rewrite this one as 3 to the 3rd. Now we're getting somewhere. These two exponents multiply together. I'm going to do that in a different color here. We'll go with purple when I circle these. There we go. So that's going to become 3 to the 8x minus 6. Make sure that you distribute that 2 to both of these here, okay? And don't leave that negative 3 out. He still wants to join the party, right? Equals 3 to the third. Now I have the same base. I can set my exponents equal, just like we did with those logs, with that one-to-one property of logs. It applies to exponents as well. Add 6, I get 8x equals 9. Divide by 8 on both sides, and I get x equals 9/8. Beautiful. No real need to worry about extraneous solutions when it comes to exponentials, because the domain restrictions for exponentials are just all real numbers. There's no restrictions. Whereas with logs, it starts as x is greater than 0, and if there's any kind of shifting, then we would change those domain restrictions, but that's why we can have extraneous solutions with logs, not so much with exponentials. Okay, next one here. Oh boy, fraction. Mr. Allen, you're killing me. You're killing me. Oh, wait, I am Mr. Allen. Okay, so let's see here. We've got, can we rewrite these with common base? Yes. I could do 2 to the negative first, right? I'd have x squared plus 4x still equals 2 to the third. We should be comfortable with our 2s, our 3s, and our 4s, and probably our 5s as well, with rewriting with like bases, right? We can get up to 6, 7, and 8, but we'd only probably do to like the second power on the non-calc, so you're probably okay without those. But mainly our 2, 3, 4, and 5s, I'd make sure that you're solid on those. So now I'm going to have 2 raised to the negative x squared minus 4x equals 2 to the third, and I can have negative x squared minus 4x equals 3, one-to-one property of exponents. Now here's the thing. You could bring the 3 over to the left-hand side. I'm not going to do that. You want your quadratic term positive. Do not try to factor with a negative coefficient, okay? It never works out well. So I'm going to have x squared plus 4x plus 3, and now I'm going to have 0 equals x plus 3, x plus 1. What multiplies the 3, multiplies the 3, yep, and adds the 4 would be 3 and 1. I'm running out of space. I'm just going to write down our answers here. X equals negative 3, x equals negative 1, and they will absolutely both work if we plug them back in. That is super dang dope. Dos mas, dogs. Dos mas. And I noticed the first typo here. Hopefully there weren't any others. This looks like this should be E, and then I think this should be F, if my alphabet is correct. But, you know, it happens. All right, cool. Awesome. Next one here. I was doing this thing today. My battery was dying on my work laptop, and I didn't have my charger, so I was like, 23 minutes left till it shuts down, and was able to get it done. Okay, so now here we have, oh boy, we got a whole lot of logs. Let's condense on the right-hand side, right? So I'm going to have 3 log base 7 of x equals, and then we'd have log base 7 of 4 times 16. Oh my goodness, I can hear you guys complaining from here that you don't know what 4 times 16 is. All right, it's 64. That'd be awesome if I did not get that right. Okay, so now I have log base 7 of x, and I'm going to bring this guy up as an exponent here, so that now I have a log base 7 equals a log base 7, and I can use one-to-one property of logs. My logs is gone, baby, and I got x cubed equals 64. So if I cube root both sides, cube root or raise to the 1/3, whatever you want to do, however you want to slice it, we get x equals positive 4. Beautiful. That's dope, man. That's dope. Now, if it were x squared, you would have plus or minus 8, but that negative would not have worked in the original because that log base 7 of x, right? That would be a negative argument in our log. Can't have that. Cannot have that. Last one here. Man, the boats are cruising. I'm going to get out there here in just a sec, all right? But I had to get these videos done just for you dogs. Alrighty, so I'm going to subtract 3 first. Let me get a different color here so things don't mix in. Minus 3. Whoop. 4 to the x squared minus 10 equals 16. I can rewrite this. So we got 4 to the x squared minus 10 equals 4 squared, right? 16 is the same as 4 squared. Oh my goodness. There seems to be some kind of a pattern here of getting like bases and setting my exponents equal. There is, right? X squared minus 10 equals 2. I'm going to add 10, and I get 12. Why did I do that instead of set equal to 0? I'm not going to factor on this one. I'm going to use square roots to solve. So I'm going to get x equals plus or minus, and then 12, root 12. That can break down into 2 and 6, 2 and 3. Circle your pairs. We get 2 root 3. That's a pretty common one. Some of us might even remember it without doing the factor tree, but there we go. We got plus or minus 2 root 3. You need both solutions there for that one, dogs. Don't forget that plus or minus, or you will lose a point. You might think that that's ridiculous to lose a whole point, not a half point, but it's one whole solution, okay? One whole point, one whole solution. That's about it, dogs. I think that's it. That's the whole review. Look at that. It's done. It's done. We got a whole thing done. Dope video, dope key. I appreciate you guys watching. Hopefully it was helpful. Again, if you find any mistakes in this video, email me, put it in the comments, be like, bro, you screwed up. And then come by for a sick Yoro sticker, a TI sticker, something like that, or maybe some extra credit if you're actually in my class and I can authorize those kind of things. You guys have a fantastic day. Thanks for watching. See you dogs later.